June 2005, Core 4, question 7 is the vectors question. We're first of all asked to find out the length between A and B, so we're going to need to know what A to B is, aren't we? Let's find out what A to B is. We're going from 1 to 2, so that's 1. We're going from 4 to -1, so that's down 5. And we're going from 2 to 3, so there's another 1. So we've got A to B is 1 minus 5, 1. And to find the length of that, we're going for the square root of all these things squared. And we got, what, 25, 26, 27, square root of 27. Not quite what we wanted, but a bit of core 1 will remind us that 27 is 9 times 3, and the square root of 9 is 3. So we have indeed got the 3 root 3 that we wanted. Now we're going to find out the acute angle that that line makes with the line L. The line L, we only care about the direction of that bit this time. And we're looking at the A dot B formula. The A dot B formula is A dot B equals the length of A, the length of B, cos theta. A, well, we'll take that as what we just found out, the 1 minus 1, 5 from here. And B will have the direction of the line. The length of the line we did earlier, that's 3 root 3s. That means we've got to find out what the length of B is. We've got to find out what the length of this is. Well, 1, 1, 1, 1 squared, 1 squared, 1 squared, square rooted. It's just going to be root 3, and I'm timesing that by cos theta. This side here, I've got root 3 times root 3, which is 3. 3 times 3 is 9. 9 cos theta, I was hoping for that. And on this side over here, I've got 1 times 1. 5, well, minus 5 times minus 1, and 1 times 1 here, so 5, 6, 7. I've got 7 ninths. So I divide both sides by 9, and I've got cos theta equals 7 over 9 as we were asked for. We weren't even asked to find out what the angle is, so we can leave that there. Let's get some more room now then, because we've now got to find a point on the line where lambda equals P, and we've got to try and find out what A to P is. Let's write down what A was again. A was the point in the question at the beginning. A was the point 1, 4, 2. And point P is now the point on this line that's got sort of a lambda in that. Instead of the lambda, we'll put a P. So I've got 2 plus P, minus 1 minus P, and I've got 3 plus P. I'm getting that just from putting a P in here. So 2 plus P, and so on. I need to find out what A to P is. And so how do I get from 1 to 2 plus P? Well, it's an extra 1 plus P. How do I get from 4 down to minus 1? That's minus 5 minus P. And how do I get from 2 to 3 plus P? So I need an extra 1 plus the P. So there's my A to P. And it suggests that what we're going to do with that is we're going to dot it with the direction of the line. So here's what I just decided that is. Direction of the line was 1 minus 1, 1. And so should we write all this out? So we're going to get 1 plus P minus 1 times this. So it's just plus both of those. And then we've got one of these, 1 plus P, which gives us 7 plus 3p, as they said it would be. The perpendiculars meet at 90 degrees. 90 degrees has a cos of 0, and a cos of 0 means the dot product that we just did is going to be 0. So take away 7 and divide by 3 gives us p equals minus 7 thirds. The last bit says, well, what would the coordinates of this foot of the perpendicular be? So we're going to drop that in each of these places here, and that will tell us that our final position is going to be minus a third, and then we're going to get 4 thirds and 2 thirds. Take time on it. There's your vectors question.